So today we're going to start Chapter 12. We're going to talk about polyphase systems, specifically three-phase systems. And this, again, it's not a particularly difficult topic in the sense that we're not learning anything like a new version of nodal analysis or any of that. The only thing that gets a little bit confusing about these three-phase circuits is that we try to simplify them. And it's in that simplification, which is great. It helps so that we only have to try to analyze one of the three phases. However, then you have to be careful about what the relationship is between, the style you're looking at, or like the style of the load versus the style of the supply, and things like that. So, first we'll talk about what a three-phase circuit is, and then we're going to talk about the balanced version. So balanced three-phase voltage or voltage supplies, and then how those connect to loads. We're going to talk about power in the balanced system. And then in the end, next class, we'll talk about, we may not quite finish power today, but in the end, we'll talk about unbalanced three-phase systems. And then really the important thing of three-phase circuits is why do we use them, right? What are the applications, and especially in distributing power. So, at its heart, what is a three-phase circuit? In a three-phase circuit, we have three distinct sources operating at the same voltage, but 120 degrees out of phase with each other. Right? So they have the same amplitude, the same frequency, right? So we can write them as phasors, and we can compare them. And in this case, they're all three connected to the same ground terminal, right? But each applying a slightly different phase of voltage to the load. This is a four-wired system because the three supplies are connected like a Y. So if I were to look at this and redraw it, there will be some images later that show it that way. But you can see there's a common point in the middle and 1, 2, 3 legs coming out. So that's like the Y. That type of a configuration, which allows us to make a neutral or common connection to all of our supplies. So that's one advantage of the Y system. You get the neutral wire connection in the middle. So that allows a four-wire system. Right? In this case, we can also see we have three distinct loads. Right? They're connected to each of the lines coming off of our system. But that's really what we mean by three-phase. So if I were to look at this right away, I could solve this, right? I could do superposition, right? I have three different sources. I could just turn each of them off and see what happens over on the rest of my circuit. I could apply all of my standard circuit analysis techniques to figure out what's going on in this three-phase circuit. So, at its core, three-phase circuits are nothing new. It's exactly the same as everything we've been doing in chapters 10 and 11, right? You can always fall back on nodal or mesh analysis or superposition or any of those, right, to solve what's going on in a three-phase circuit. But again, the beauty of it is because there's a lot of symmetry involved, we'll be able to simplify this. So again, why do we want a three-phase circuit? Well, there are some very distinct advantages. Most of our electric system, right, our actual grid, is distributed using three-phase power. So it might be useful for you to know how to do three-phase power because you're going to connect to the electrical grid. So it's kind of a good idea to know how the power is coming in and how it's working. Right? Also, the nice thing about a three-phase system is that unlike a single phase, right, where we had just one supply, when we looked at the instantaneous power, right, it was going up and down and up and down. It was constantly changing, right? We calculated an average power, but the instantaneous power changed at every moment in time. In a three-phase system, we can actually have a constant instantaneous power. So that's pretty nice. Also, for the amount of power that we want to supply, the three-phase system is more economical than a single-phase system. That's why the grid uses three-phase, right, as well, because it saves a lot of money to build the distribution system for three-phase. So we'll go through, what that economical advantage is. And one of the other big reasons that it's more economical is that it requires less wire than, less copper than an equivalent single-phase system. That might seem a little bit strange. How is it that running 3 wires is going to be cheaper than running 1 wire? Fundamentally, it comes down to the fact that each wire is significantly smaller. Because now, instead of 1 wire having to carry all of my current, I have 3 wires carrying much less current. And if you think about the resistance of a wire, right? It goes like the length of the wire divided by the cross-sectional area of the wire. So if the current goes down, the cross-sectional area can go down. And so the total volume of copper I use is much less, even though I have 3 wires I have to run. So when you walk around outside and you look at the power poles, you'll usually see 3 wires running together, right? And those are your 3 distribution wires carrying your 3 phases. When it comes down into an individual building, not a commercial building like this, we get 3-phase power into the building here. But like at your home, you'll usually, what they'll do is just on the power pole outside, they'll just draw one of the phases off and send it down to your house. So you don't get 3-phase power in your house. You get single phase. And they do that with those little gray transformers, the little gray cylinders you see mounted up on the poles. Those transformers step down the voltage and send 1 phase off to maybe a couple of houses around the area. So 3-phase power has a lot of advantages to it, right? Despite being maybe a little bit more complicated.